Now we're going to review chapter 12. Okay. Okay, so chapter 12, here we go. So chapter 12 is our history from the beginning of the universe until today. So, how much of Earth's history is in the Precambrian? So this is a review of what we saw in chapter 11, but this is now chapter 12, number 1, about how much of the Earth's history is in the Precambrian. And you can round up. So rounding up, the Earth's history is 90% of it is in the Precambrian, so that's E. Alright, so chapter 12, number 2. What supercontinent, all this Pangea, broke up during which period? So let's see, Pangea broke up in the Mesozoic. So Pangea broke up in the Mesozoic period. So while the dinosaurs were still, began to break up in the Mesozoic while the dinosaurs were still around, so that's B. Okay, chapter 12, number 3. Which gas, the early Earth was missing an important gas, and what gas was that? And the early Earth was missing a gas that we take for granted today, and it was missing free oxygen. So there was oxygen, but not free oxygen. Oxygen gas in the atmosphere. So that's D. Okay, chapter 12, number 4. What is the Cambrian explosion? Okay, so the Cambrian explosion, let's see what it was. It was an explosion of biodiversity. Explosion of biodiversity. Biodiversity, so this is A, and the reason why is that for 88% of Earth's history, life was in a form of squishy bacteria, and then all of a sudden you have animals that emerge that have a hard outer shell, and that allows these animals to live in a variety of different environments, and because of that they become a whole range of new different species. Okay, chapter 12, number 5. What adaptation allowed reptiles to become the first land-based mammal so that they didn't need to go back into the ocean anymore? Excuse me, let me repeat that. I said that incorrectly. What adaptation allowed reptiles to become the first fully land-based vertebrates, meaning that they didn't need to go back into the ocean anymore? So the major adaptation was shell-covered eggs. And what shell-covered eggs did is that the babies were able to stay in a watery environment, but the watery environment was inside the egg, so that they didn't need to go back into the ocean anymore. Okay, chapter 12, number 6. In the Mesozoic, what was the dominant life form during the Mesozoic? So the Mesozoic is the age of the reptiles or the age of the dinosaurs. And so that's B. All right, chapter 12, number 7. In what period did humans evolve? So humans are mammals and they evolved in the Cenozoic period. So that's D. And the Quaternary is the last part of the Cenozoic period. Okay. Chapter 12, number 8. So the early Earth was molten. So what caused the Earth to be molten? And these pictures are hints here. So there are two reasons for why the early Earth was molten. So the first one is that the early Earth, the early solar system was full of debris, so there were constant collisions. And collisions cause friction, and friction causes heat, and heat melted the Earth. So there were repeated collisions between Earth and other objects in our solar system. So there were repeated collisions with planetesimals. And there's something else. Originally, the Earth was more radioactive, so there was a lot more plutonium and uranium, and those radioactive elements release heat, and that heat also contributed to the melting of Earth being molten. So also because of radioactive decay. And both of those things caused the early Earth to be a magma ocean. Okay. Chapter 12, number 9. What is another name for the Hadean eon, or what is another name for the Hadean? So Hadean is the very beginning. So this means ancient age. But Hades, or Hadean, comes from Hades, which means underworld or hellish, because it was, everything was molten, constant collisions. Okay. Chapter 12, number 10. Okay, so this is a two-part question. So A, how was the Earth's magnetic field formed? And B, what does a magnetic field do for life on Earth? So this is a hint for A, and then this is a hint for B. So let's see. When the Earth was molten, the metals are heavier, so all the metals sank. All the iron sank, or the metals sank to form the core. So when the Earth was molten, all the iron sank, all iron and nickel and metals sank to form the core. And as the metals sank, the Earth had two different layers. It had the outer core and the inner core. And so let's continue on with A. So you have the core, and then the inner core is solid, but the outer core is made up of liquid iron. And liquid iron, it's electricity, and whenever you have electricity you get a magnetic field, and so that's where the Earth's magnetic field comes from, is liquid iron circulating in the outer core. So that's A. And B, so let me actually be clear here. So I explained the formation of the core, but actually what we want to concentrate on is where the magnetic field comes from. So the magnetic field directly, it comes from molten iron in the outer core. Molten iron in the outer core. Oops, excuse me. Molten iron in the outer core. And what the magnetic field does for us is that you can see here that the sun doesn't just send light, it sends streams of electrons and protons. And without the magnetic field, those electrons and protons would be constantly bombarding the surface of the Earth, bombarding living things, you and me, and our DNA, and that would destroy the DNA. So actually, the magnetic field protects life on the surface of the Earth from cosmic rays. So it protects life on the surface from cosmic rays. Cosmic rays. So if it wasn't for the magnetic field, there could still be life on Earth, but the life would be not on the surface, but it would be deep in the oceans. So even today, there may be life on Mars, but if there is, it can be not on the surface of Mars, but in underwater lakes. And even on some of Jupiter's moons, they also have underwater layers. There's also water beneath the surface, so there as well, it's possible that there may be life there.